Hello friends, I am Vatsal Patel, Assistant Professor from Civil Engineering Department in Mahatma Gandhi Institute of Technical Education and Research Center, NAVSARI. Today we are going to discuss about caissons. So first, caisson is derived from the French word caisse, meaning a box, and it is relatively a large deep foundation. It is a box-type structure in shape of rectangular round which is sunk from the surface of water or land to a desired depth. It is permanent structure and a part of the substructure. So uses of it: transferring the load of structure to the hard strata, used for the foundation of bridges, piers, abutment in river or lake, also used as an impervious core wall of earth dams and to provide an access to a deep shaft or tunnel. So material. Now following material are used for the caisson. First one is RCC, then after steel, then after timber, and then after cast iron. So types of the caisson. Box caisson. Box caisson is which is open at top and closed at the bottom. Then open or well type, which is open at top and bottom, and pneumatic type caisson, closed at top and open at bottom. Next, box caisson. It is a strong vertical tight vessel open at top and closed at bottom and made of timber, steel or RCC. It is built on land, cured and then float or launched to the site where it is placed in position according to location of its structure. Mainly it is used for the shallow depth and for lightweight structure. So it is the plan and cross sectional of the box caisson. So in which you can see water level, filling, concrete placed by terrain and rock. So box caisson. In box caisson, the caisson is sunk by filling sand, gravel or concrete in the empty space inside. The place where the caisson base is to rest must be level, such as box caisson are used in a place where the strata of sufficiently bearing capacity is available near the ground. In normal practice, the soft natural bottom of the soil of the riverbed is dragged out to some depth and trenches formed in fill with the sand to have a level base. The function of sand layer is to uniformly distribute the superimposed load over the soil below and thus avoiding the tilting of the caisson. So this is the real life image of the box caisson. Next, open or well caisson. So common shapes of caisson are single circular, twin circular, dumbbell, double D, twin hexagonal, twin octagonal, rectangular. Next one is well component. So you can see all the well components in the figure, which are cutting edge, curb, staining, bottom plug, well cap, top plug, sand filling. So now we are going to discuss its definition or function. So cutting edge provides a sharp edge to cut the soil below during the sinking operation. Curb, during sinking it acts as an extension of cutting edge and provides support the well, and it is made of RCC. Staining, it is the main body of the well made of RCC or masonry with the minimum thickness of 45 cm. Bottom plug, made of concrete and designed for an upward load equal to the soil pressure minus sulfate of the bottom plug and sand filling. Next, wall component function. The function of top plug is to support the well cap. It transfers the load from pier to the well. Sand filling, it transfers a portion of load from well cap to the bottom plug. Next, single wall open caisson. This is box type structure having no top or bottom during construction and mainly consists of vertical wall. The method of construction of typical single wall caisson is described below. Wherever necessary, the site is made dry by dewatering the area by adopting suitable method by constructing cofferdam, sheet piling, etc. A pit of suitable size and about 3 to 4 meter deep is excavated at the site where the caisson is to be sunk. The cutting edge is then placed at the bottom of the pit. Above the cutting edge, the well reinforcements are suitably tied up and the shuttering for the casing or casting the concrete well is erected. The caisson walls are then concreted and lifted to a suitable distance. Next, when the freshly laid concrete has gained sufficient strength, sinking operation is started. The caisson sinks due to its own weight when the soil from the space inside removed by the use of clamshell or any other method. As the sinking proceeds, additional sections of the caisson wells are successively cast. Sinking is stopped while each section is concreted, and it is resumed only after concreted section has gained sufficient strength. When the caisson is sunk to the required depth, it's base plugged by the providing 15 to 45 meter thick layer of concrete or say concrete seal. The concrete for the seal is placed by the use of trimmy pipe or by a bottom dump bucket. After the concrete seal has set, the water inside the caisson is pumped out and the empty space is filled with sand or gravel. The rate of the sinking of the caisson is always slow because the downward movement of the caisson is resisted by the screen friction of the ground on its wall, and at the times the screen friction becomes so great that the caisson does not sink even after all the earth has been dragged out from the inside and cleaned down to the cutting edge. In such situation, sinking is restored by loading the caisson with the additional weight in the form of rail, ignite block of steel, etc., which are removed afterwards. So next one is cylindrical open caisson. This may be defined as a cylindrical shell made up of timber, masonry, steel or reinforced concrete should with a cutting edge and which is sunk by excavating a soil within the shell. The thickness of the caisson wall must be adequate so that when the inside soil is stretched out, it sinks under its own weight. To facilitate the sinking of the caisson, water jets are sometimes used around the sides, which decreases the screen friction. Cylindrical open caisson is also known as well caisson. This type of caisson is similar in all aspects to the single wall open caisson except that its wall is circular in plan. In the method of construction of well caisson, it is exactly similar to that of single wall caisson described earlier. After the well is sunk to the desired depth, of bottom is sealed with concrete, and this type of caisson is commonly adapted for providing foundation for bridges. Next one is most important topic. So next, moving on, pneumatic caisson. So this type of caisson is closed at top and open during construction at the bottom. The water is excluded from the caisson chamber by means of compressed air. So the construction of the pneumatic caisson is similar to the described above, except that the working chamber and shaft are made airtight. In order, the workmen may carry out excavation work underneath the caisson and the water may not find its way inside from below. The pressure of the compressed air in the shaft is kept just higher than that of the water at the depth. So in each caisson has two airlocks. Through one airlock, workmen go down for working, while through the another excavated material is taken out. An airlock is essentially consists of a steel chamber having two airtights. So next, one door of this chamber serves as an entry for men and other is for material from the outside into the steel chamber, and other doors leads to a air shaft. When a workman enter a airlock from outside, the pressure inside the airlock is the same as that of outside atmosphere. Thereafter, the outside door is closed and the pressure inside the airlock is raised slowly. When the pressure inside the airlock becomes equal to the pressure in the caisson, the door of the airlock which leads to the air shaft is open and the workman goes down the air shaft with the help of ladder installed within. Exactly reverse procedure is followed when the workmen come out from the caisson, and air shaft provide means of access for the workmen for the airlock. Next, in this method, providing foundation is complicated, expensive and very slow. However, in places where it is rather difficult to use bulky equipment required for alternative method, pneumatic caisson appear to be only choice. The chief advantage of this method is the entire operation of sinking caisson can be carried out under a controlled condition. This method provides better facility for removing obstruction, inspection of work and concreting of foundation bed. This type of caisson is suitable for depth ranging from 25 meter to 40 meter. At higher depth, the person working inside caisson for sinking operation are liable to get caisson disease. So this is the diagram of pneumatic caisson. You can see that in image. Next, pneumatic caisson sickness. When worker work under compressed air inside the working chamber, they suffer certain type of disease when they return to the atmospheric pressure. This disease is known as caisson sickness or caisson disease. So the main type of symptoms of disease are dizziness or say vertigo, double vision, headache, trouble to speaking and pain in body. So next, moving on the most important topic, pneumatic caisson sickness or say its precaution. So the precaution taken for the pneumatic caisson sickness are: no person should work for more than one shift in a day. Shift should not exceed 12 hours. Temperature of the working chamber should be maintained 25 degrees centigrade. The main locks should be well ventilated. Person with strong Heart, low blood pressure and good circulation should be employed on the work. Use of alcoholic drinks should be prohibited. Medical facility or chamber should be provided near to the work. The workers should take enough meal before the shift starts. All the passages, shaft, etc. of the caisson should be well ventilated and properly lighted. The worker use meal log for entry, interval and